Let's look at number 9. We have x minus 2 cubed. Now this is a problem that we have talked about in the past couple days because there is something that a lot of us want to do that we cannot do. Is it okay if I just distribute or give that 3 to the x and to the 2 like this? The answer is no. That is not what this means. This means we have x minus 2 times x minus 2 times x minus 2. We have 3 x minus 2's. So that's what we're going to have to do is distribute multiple times. I start with the last 2 just so that I still have an x minus 2 out front. So what I'm going to do is bring down this x minus 2 that I'm not using yet. We only know how to distribute with 2 at a time. So bring down the x minus 2 and we are going to distribute this x minus 2 to the next one. So x times x gives us x squared. X times negative 2 gives us negative 2x. Now we take that negative 2 and distribute it. So negative 2 times x gives me negative 2x, and negative 2 times negative 2 gives me a positive 4. Before distributing the x minus 2, let's combine our like terms. So bring down the x minus 2, nothing has changed. We have x squared, negative 2x minus 2x gives us negative 4x, and then a positive 4. Now we can take this x minus 2 and distribute it. So let's distribute that x to every single thing. X times x squared gives me x cubed. X times negative 4x gives me negative 4x squared. X times 4 gives me positive 4x. Now distribute the negative 2 to every single thing. So negative 2 times x squared gives me negative 2x squared. Negative 2 times negative 4x gives me positive 8x, and negative 2 times 4 gives me negative 8. We're almost done. We just need to combine our like terms. So I have a negative 4x squared and a negative 2x squared. I see a 4x and an 8x. That x cubed just stays. Negative 4x squared minus 2x squared gives me negative 6x squared. 4x plus 8x gives me 12x. And then that negative 8. So be very careful on these problems. We cannot just give that 3 to everything. This means we have 3 sets of parentheses. So then we're going to have to distribute multiple times. On the back of the notes, I'm going to write out the next 2 problems, and I want you to try them on your own. So here is number 10. Number 10, we've got 2x squared plus 1 times x plus 2. Pause the video, try it on your own, and then check your answer in a minute. All right, let's check it. We're going to distribute the 2x squared to everything, so that gives me 2x cubed plus 4x squared. We'll distribute the 1 to everything, so that gives me x plus 2. And there are actually no like terms here, so we're finished. All we had to do was distribute. Now I want you to do number 11. Number 11 is x plus 3 cubed. Be so careful of this. Remember, this does not mean x cubed plus 3 cubed. No. So I want you to pause the video, try it, and then check your work once you finish. All right, we know that this means x plus 3 times x plus 3 times x plus 3. So I'm going to start with the last 2 and distribute them. While I bring down that x plus 3 that I haven't used yet, and then these, when I distribute them, distribute the x, distribute the 3, and that's going to give me x squared plus 3x plus 3x plus 9. Let's combine our like terms. Bring down that x plus 3, x squared plus 6x plus 9. Well, now we can distribute this x to everything, distribute the 3 to everything. So that's going to give me x cubed plus 6x squared plus 9x. And then when we distribute the 3, plus 3x squared plus 18x plus 27. Last step, we need to combine our like terms. So 6x squared plus 3x squared, 9x plus 18. So we have x cubed plus 9x squared plus 27x plus 27. So let's look at number 13. Are all the answers to these problems polynomials? Every single one that we've looked at on the front of the page, on the back of the page, they were all polynomials. How do we know? Because they have whole number exponents. Well, if the answer to that is yes, then take a guess at what it means about the product of polynomials. Well, that means that polynomials are closed under multiplication. Just like they are with addition and subtraction, they're closed under multiplication. That means if I multiply any set of polynomials, no matter what they are, I will always end up with a polynomial. Last thing we're going to look at is two special cases. And these special cases actually make some of our computation much easier. So first we're going to look at square of a binomial pattern. A square of a binomial, well, square means to the second power. Binomial means two terms. So if I have a plus b squared, then instead of writing them out and distributing, what I can do is a squared plus 2ab plus b squared. If I have a minus b squared, the square of this binomial, then I can do a squared minus 2ab plus b squared. First thing I want to do is look at why this works with a graphic organizer. So we're going to take a plus b squared and make a graphic organizer. So I put a plus b on the top, a plus b on the bottom, and we are multiplying them. So a times a gives me a squared, a times b gives me ab, b times a gives me ab, and if you wrote it as ba, these mean the same thing. And then b times b gives me b squared. Well, when I use a graphic organizer, I can look at my like terms. So this ends up giving me a squared plus ab is 2ab plus the b squared. So this is how it works. That has just been proven that a plus b squared equals a squared plus 2ab plus b squared. And what I'll talk about here is the middle term. I'll call ab the middle term sometimes. So I'll say do 2 times the middle term. How do we get the middle term? We just multiply the a and the b. And we're going to look at examples of this right now. So let's look at number 14. What if we have x minus 5 squared? You have two options. One option is memorize the rules. I would highly encourage that, because if you memorize these, it is really going to help you in the long run once we start factoring, which we'll do later. So I would really encourage you to memorize. If you refuse to memorize them, that's okay. That's on you. You can just distribute them. So we're going to do this 2 different ways. Okay? First way is using the square of a binomial rule. Well, x minus 5 squared. We know that x is a, and we know that 5 is b. So x minus 5 squared is equal to x squared. Remember, we're using this. Now in this one, we have a minus b. The only place we see a negative sign is right there with the 2. So x squared minus 2 times a is x, b is 5, and then we have plus b squared, so plus 5 squared. Notice, I didn't take the negative with the 5. The negative is just used right there. So this is how we write out the rule. Well, x squared, we have a negative 2x times 5. So negative 2 times 5 gives me negative 10, and then the x, and then 5 squared gives me 25. So that's how we would use this rule. Square the front, square the back, multiply x and 5 together times 2 to give us the middle. Okay? So now, if you did not want to do it that way, then we can do x minus 5 times x minus 5 by distributing. So x times x is x squared, x times negative 5 is negative 5x. Then we do the bottom, negative 5x, negative 5 times negative 5 is positive 25. Combine your like terms, and we have the same answer. Let's look at another example, number 16. 2x minus 3 squared. Go ahead and try to do this one in your head or on your paper, and then check back and check your answer. All right, if we use the rule, which I would really encourage you to do, then we are going to square the front term, do 2x squared. We're going to multiply the middle, 2x times 3 gives us 6x, and multiply that by negative 2. It's negative because that's negative. So I did 2x times 3 to get 6x, and then at the end, we multiply the last term. So first term squared, multiply those times negative 2, and then last term squared. Well, 2 squared gives me 4, and x squared. Then I have 2 times 6, x, and then 3 squared gives me 9. Again, if you decide not to do the rule, then you can do 2x minus 3 times 2x minus 3 and distribute and distribute. So then that would give us 4x squared minus 6x and then negative 6x plus 9. Combine your like terms. Same answer, okay? If you did this top one, you don't have to write this one down because you know the rule. Try one more of these. We have 3x squared plus 2 squared. Again, I want you to pause it, try it, and then check your answer. All right, if we use our rule, then we're going to take the first term squared. This time, because it's a positive on the inside, we're going to take a positive 2 and multiply it by 3x squared times 2. Well, 3x squared times 2 gives me 6x squared. And then at the end, I take the last term, 2, and square it. Well, 3 squared gives me 9, and x squared squared, remember here we multiply the exponents, so that's x to the 4th. Then in the middle, I've got 12x squared, I just multiply, and 2 squared gives me 4. If you distributed, then you will get the same answer as we did. Let's head over and work on the last rule. So this one was a square of a binomial pattern. Now we're going to look at difference of two squares pattern. Well, this means we have a plus b times a minus b. And if we have this case, one is a plus and one is a minus, then we can just take a squared and subtract b squared, and that's our answer. So let me show you why this works, again using a graphic organizer. If we put a plus b on the top, and then put a minus b on the side, well, a times a is a squared, a times b is ab. Then we have negative b times a is negative ab. If you wrote it as negative ba, those mean the same thing. And negative b times b is negative b squared. Well, what do you notice here? When I look at my like terms, I've got ab minus ab. Those cancel. All I'm left with is a squared minus b squared. Okay? This one's one of my favorites because it is so easy. So let's look at number 15. We have x minus 7, x plus 7. I know I can use this rule because I have a minus and a plus with all the other same stuff. So what do? We take the first term x and square it. Then we subtract the second term 7 and square it. Well, x squared and then minus 7 squared gives me 49. Now, if you refuse to learn this rule, which I would really encourage you to learn it, if you don't want to, though, you can multiply them as usual. Distribute the x, distribute the negative 7. Okay? Here are the next two problems. I want you to pause the video, write them down, and try it on your own, and then check your answers. All right, for number 17, using the rule, we take the first term squared. So 2x squared, we have 2 squared gives us 4, and then the x squared, and then 3 squared is just 9. So we're done. On the next one, we have 3x squared squared. So that 3 squared gives us 9, and then x squared squared, multiply the exponents, so that gives x to the 4th, and 2 squared gives us 4. Remember, this rule only works if we have the same thing, just a plus in one and a minus in the other, And then if you don't want to learn it, you can just distribute like we learned on the